S is a set of all real x such that this expression is positive, then S equal to the interval is minus infinity to 1. So we need to check whether it is true or false, where S is a set of all real x, right? So this expression is given to be as positive, and we need to find an interval for which this expression is positive. So this is the given expression that is positive. How can I write this further? I can write this as 2x minus 1 divided by, let's make the factors of the denominator. If I take x common from this, I get 2x square plus 3x plus 1, right? And after that, let's factorize this also. So this is 2x plus 1 into x plus 1. I want to make the powers of the factors in the denominator to be even, so that afterwards we will work on only for the numerator. So for that, what I have to do is, let's multiply and divide by x. So the power of x in the denominator becomes 2. So this is x square. And then let's multiply and divide by 2x plus 1. And then in the denominator it becomes 2x plus 1 whole square. After that, let's multiply and divide by x plus 1 also, so that I can get x plus 1 whole square. Fine? Alright. Let's take 2 common from the numerator from these two factors. So this becomes x plus 1 half, x minus 1 half, and x plus 1 is multiplied, divided by, let's also take 2 common from this factor. So this becomes 4 x square into x plus 1 half whole square into x plus 1 whole square. So these two cancelled out. Now in the denominator we are having the powers of the factors to be even. It is completely positive. Let's get back to the question now. They are saying that if S is a set of all real x such that this expression is positive, which means this numerator is also positive. Let me call this numerator to be as E. Now because the denominator is completely positive, we will only have to work on the numerator now. I need to get the intervals for which this numerator is positive, right? So for that, let's make a number line. What points should I plot here? This x plus 1 can be seen as x minus minus 1, right? And this x plus 1 half can be seen as x minus minus 1 half, right? And this x can be seen as x minus 0, and it is already x minus 1 by 2. So we are going to plot negative 1, minus 1 half, 0 and 1 half, right? So this is minus 1 half, this is 1 half, this is negative 1. That's it. Let's divide this number line into the intervals. Let's check what sign I'm getting for the factors for the values of x which are less than negative 1. So the values of x which are less than negative 1, what sign is given to this factor x plus 1? It is, for the values of x less than negative 1, it is negative, yes. And x plus 1 half for this factor, what sign I'm getting? Again negative. X itself will be negative. And for the factor x minus 1 half, it is also negative. So we are getting the sign of all these factors to be negative for the values of x which are strictly less than negative 1. Now let's check the sign of the factors for the values of x lying in this interval, minus 1 to minus 1 half. So for x plus 1, I am getting positive sign. If you take the value of x to be greater than negative 1 and less than minus 1 half, I get the value of x plus 1 to be positive. Then what is the sign for x plus 1 half? It is negative. X itself will be negative, and x minus 1/2 is getting the sign again negative. Right? Okay. Similarly, let's check the sign of the factors for the values of x lying in this interval. X greater than minus 1/2 and less than 0. For this, I'm getting the sign of x plus 1 to be positive. The sign for x plus 1/2 is again positive. X itself is negative. And x minus 1/2 is getting the sign to be as negative. Getting the sign of the factors for the values lying in this interval. X greater than 0 and less than 1/2. For this, x plus 1 is getting the sign positive. X plus 1/2 is also positive. X itself is positive in this interval and x minus 1/2 is getting the sign negative. Because we have to take the values of x less than 1/2, right? Okay. Getting the sign of these factors for the values of x greater than 1/2. For that, x plus 1 is taking the positive sign. X plus 1/2 is also having the positive sign. X itself is positive and x minus 1/2 is again positive. Right? Now let's check the sign of E for the interval in which the values of x is less than minus 1. That means we need to take the product of all these signs, right? Because E is the product of all these factors. So what sign E will get for the values of x less than minus 1? Yes, product of all these negative signs is positive. In this interval, what is the sign is? Plus minus is minus, minus minus is plus, and this plus and this minus will become negative sign. Right? Understood? Okay. The product of these two signs is positive. Product of these two signs is positive. So product of positive and positive is positive. Product of these three signs is positive, and positive and negative becomes negative. Please remember, we are getting the product of the signs. And the product of all these signs is positive. So in which interval we are getting E to be positive? That interval we need to write now. Let's take the union of those intervals for which E is strictly positive. So where E is positive? In this interval, and in this interval. So thus, E is positive if x belongs to, okay, the first interval is from minus infinity to minus 1 union, from minus 1/2 to 0 union, from 1/2 to infinity. Right? Hence, S is equal to minus infinity to minus 1 union, minus 1/2 to 0 union, 1/2 to infinity. So this interval is not the solution. So this statement is false. Alright, thank you.